Most people have met a chatbot. Ask a question, get an answer. Helpful, but it stops there. An AI agent is something different. It doesn't just reply. It pursues a goal over multiple steps. It keeps track of what happened, chooses what to do next, uses tools in the outside world, and adjusts when things don't go as expected. The big difference from a familiar chatbot comes down to state. A chatbot is stateless. It treats each prompt like a fresh start. An agent is stateful. It remembers the plan, the actions taken, and the outcomes so far. That memory turns one-off replies into a continuous problem-solving loop. Why care? Because real work isn't a single question. It's a sequence. Collect information, run a check, write a draft, fix an error, send a confirmation. If that sequence can run in seconds instead of hours, teams save time, customers get faster answers, and systems become less brittle. Think of it like a brilliant consultant who can answer almost anything when asked directly. As a chatbot, that consultant gives a single polished answer and waits. As an agent, that same consultant carries a notebook and a phone. Notes track what's been tried and learned. The phone dials into tools and other specialists. With a clear goal, the consultant breaks the work into steps, calls in the right help, and adapts to what actually happens. So the simple version is, a chatbot answers in one shot. An agent runs a loop. Plan, act, observe, update, until the goal is done. Let that sink in for a moment. Here's a crisp mental picture. The agent receives a goal and gathers context, like recent messages and relevant documents. That becomes its view of the situation. It sketches a plan, chooses an action, and calls a tool, maybe a database, a web service, or another agent. It watches the result, updates memory, and decides what to try next. Repeat that loop until the target is reached. One agent can do a lot. Several agents, coordinated, can handle entire workflows end to end. Before getting into mechanics, a few terms in plain English help anchor the conversation. Tool use means an agent can call external systems, APIs, databases, search, email. Memory comes in two flavors: short-term, which is the immediate context of the current task, and long-term, which is information saved for future runs. Orchestration is the conductor that keeps multiple agents working in the right order with the right information. Now, dial into how this loop actually works in practice. It starts with perception and state. The agent receives a goal, process a loan application, triage a support ticket, generate a weekly sales summary. It pulls in what matters: the recent conversation, the task details, and any relevant documents or records. If there's a knowledge base, it retrieves the pieces that might help. That bundle is the agent's current understanding. What matters here is continuity. Without state, the agent can't remember which fields were missing, which API failed, or which version of a document was approved. With state, a single model call becomes part of a chain that can move forward or back up and try something else. Next comes planning and decision-making. The agent breaks the goal into manageable moves: fetch the application, verify documents, check credit, assess risk, draft the agreement. Each move becomes a candidate action chosen based on the current state and the tools available. The key idea is that an agent doesn't just write the answer, it decides what step to take. That's the pivot from reactive to proactive. Action means tools. A language model on its own can only produce text. To change anything in a real system, the agent calls an external tool: a credit bureau API, a CRM, a calculator, a web scraper, even another specialized agent. The model generates the tool call, the system runs it, and the agent gets back a result. Tools are not intelligence. They're hands and eyes in the world outside the model. Then comes observation and state update. The agent reads the result: data, success, failure, timeout, error message. It writes that into memory. If the data fills a gap, the plan advances. If the call failed, the plan changes, or the agent asks for clarification. This is the feedback that keeps the loop on track. Put differently, adaptation depends on fresh evidence. No observation, no course correction. And now reflection. Is progress actually being made? Are retries repeating the same failure? Should the route change? Use a different tool? Wait for missing info? Or escalate to a human? Thoughtful agents include guardrails to avoid loops and drift, like a retry counter or a rule that halts after conflicting signals. When multiple agents participate, orchestration becomes the connective tissue. A centralized conductor can assign tasks and pass outputs in sequence. A hierarchical setup puts a supervisor agent above specialists. A decentralized approach lets peers hand off work according to shared rules. Each option solves coordination in a different way, but the goal is the same. Sequence the work, manage data flow, and resolve conflicts so the whole system feels like one capable unit. Close the loop with completion and persistence. When the goal is met, the agent saves what mattered: key decisions, tool outcomes, and useful snippets in long-term memory. That improves the next run and creates an audit trail. There's a quiet kind of magic here. A system built from text predictions and simple loops can steer real processes across databases, APIs, and teams. To see it in concrete terms, walk through a loan application. A customer submits a request for $50,000 over 5 years. The orchestrator receives the goal. It starts with a document verifier agent that checks the application for completeness. If income proof or ID is missing, the state records "waiting for income verification," and an automated request goes out. Once complete, the credit checker calls a bureau API and returns a score, say 720. The risk analyzer combines that score with the loan amount and term, runs a model or rules, and marks the case approved, standard rate 6.5%. The agreement generator drafts the contract with those terms and stores it. The notification agent emails the customer with a secure link and next steps. Throughout, the orchestrator logs what ran, what data flowed, and what decisions were made. If the credit API times out, a retry policy kicks in, or the case goes to a human underwriter. Typical latency in a setup like that is a couple of seconds per agent call, including the external tool. End to end, the whole workflow can finish in tens of seconds rather than hours of back-and-forth handoffs. Context per agent call might be a few hundred tokens, the application data, prior outcomes, and the immediate plan. Cost scales with model size and the number of steps, often measured in cents per run. More important than the exact numbers is the pattern. Coordination shrinks the gap between someone clicking apply and receiving a clear answer. Now connect that same pattern to other domains. A customer support system can route a new ticket to a triage agent that tags the issue, a knowledge agent that retrieves relevant fixes, and a troubleshoot agent that runs diagnostics through internal tools. A DevOps incident can trigger an agent to gather logs, query dashboards, run a known playbook, and page the right team if conditions match a serious threshold. An e-commerce return can be checked against policy, stock levels, and fraud signals before issuing a label, all with the orchestrator keeping sequence and data hygiene intact. The model behind an agent is still a language model. It doesn't understand in a human sense, it matches patterns at scale. That's why tools and memory matter. It's also why retrieval augmented generation, RAG for short, fits so well here. RAG means the agent fetches relevant documents or data before it generates a response, grounding the next move in reality. In other words, agents build on RAG rather than replace it. RAG improves factuality by bringing the right information into the conversation. Agents take that grounded context and push through a sequence of actions. The beauty is balanced by trade-offs. Latency and cost grow with each step. A 7-move workflow means 7 model calls and 7 tool round trips. For real-time scenarios where sub-second response matters, that's a constraint. Tool reliability dominates outcome quality. A slow but dependable internal API often beats a faster third-party service that blips at the wrong moment. Memory has limits. Language models can only hold so much context at once. Long-running agents need to summarize, retrieve, and prune, which introduces its own chances for retrieval errors. Errors can compound. If the document verifier mislabels a field, the credit checker may query the wrong record, and the risk analyzer could approve or reject on faulty inputs. Guardrails help. Validation checks, constraints on tool inputs, and human approval points for high-stakes decisions. A clear, human-in-the-loop design, where agents collect evidence and draft recommendations, and a person approves, keeps responsibility where it belongs. What about orchestration at scale? With a handful of agents in a fixed sequence, a single conductor works well. As the number grows, or the flow branches in complex ways, a centralized controller can become a bottleneck. Hierarchical orchestration absorbs some of that by delegating oversight to mid-level agents. Decentralized coordination, where peers negotiate handoffs, increases flexibility but adds communication overhead and new failure modes. The right choice depends on how predictable the work is. One misconception is that an agent is just a smarter chatbot. Same model, different wrapper, right? Not quite. The architecture is different. A chatbot produces one response and stops. An agent carries state across a loop and can call tools to affect the world outside text. Another misconception is that agents run unsupervised. Autonomous here means they can execute a plan without manual prompts at every step, within guardrails. Oversight, validation, and auditability are essential, especially in regulated domains. There's also the idea that more agents automatically bring better results. Specialization helps until coordination costs outweigh the benefits. A small, well-defined team of agents often beats a sprawling set that spends half its time handing work off awkwardly. And finally, failures are not mysterious. With the right logs, it's usually clear whether a tool failed, a decision was made on incomplete data, or a step ran out of order. Observability, recording which agents ran, what they used, what they decided, turns a black box into a traceable system. Practical design heuristics make these systems more robust. Start simple. If a single agent with retrieval can handle the job, start there. Add specialized agents only when the single agent loop can't meet the goal or becomes hard to reason about. Give each agent a crisp role. If one agent does everything, it's not really an agent. It's a monolith wearing an agent's name tag. Choose orchestration to match the shape of the work. Linear and predictable flows lean toward a central conductor. Branching, dynamic scenarios benefit from a layered or peer model with clear handoff rules. And treat memory as a first-class component. If an agent can't remember what it tried and that it already failed, it will repeat itself. Simple signals like retry counts and last error in short-term memory can stop spirals. Tool reliability matters more than theoretical capability. An agent that calls a flaky service becomes a flaky agent. In critical paths, prefer tools with strong documentation, consistent responses, and well-understood failure modes. Where stakes are high, finance, healthcare, legal decisions, insert human checkpoints. Agents can prepare the evidence, summarize the options, and draft the proposed action. A person can approve with context that only a human currently brings. Security and integration deserve attention. Agents need scoped access to APIs and data, not blanket permissions. Role-based access, audit logs, and rate limits keep the system safe. On the enterprise side, orchestration often runs alongside existing workflow engines and message buses, not instead of them. A well-designed agent system plugs into queues, identity providers, and monitoring tools already in use. There's a moment of appreciation here. A string of tokens, words predicted by a model, can trigger a reliable sequence across many systems, provided the loop is disciplined and the orchestration is sound. That's less about magic and more about engineering clarity, explicit state, careful tool design, and transparent control flow. A quick look at limits keeps expectations honest. Context windows cap how much history the model can see. Fetching relevant snippets helps, but retrieval can miss. Long-running agents need strategies to summarize without losing important nuance. Tools that don't exist can't be called. Agents are bounded by the capabilities and data they can access. And pattern matching can lead to plausible but wrong decisions. Validation, tests, and guardrails counter that tendency. So, what distinguishes agents from classic chatbot interactions? Memory across steps, a decision loop rather than a single response, real-world action through tools, and, when many agents coordinate, orchestration that ensures the right work happens in the right order with the right data. For a lasting mental model, return to the consultant analogy. A brilliant consultant, equipped with a notebook and a phone, can break a big problem into steps, call the right people, learn from each outcome, and adjust. Add a project manager and a few specialists, and the team handles a whole project end-to-end. That's the shift from a model that answers to a system that accomplishes. Now make it actionable. When thinking about where agents fit, look for multi-step tasks that already live in tickets or checklists. Verify, fetch, analyze, draft, notify. Identify the tools those steps rely on and how reliable they are. Decide where human approval adds safety without slowing the routine cases. Implement logs from day one. They become the backbone of trust. And start small. One agent with a clear goal, then two, then three, growing only as coordination still feels clean. There's a reason this pattern is spreading. It maps well to how teams already work, and it captures gains that are practical and measurable. Fewer manual handoffs, faster cycle time, clearer audit trails. The craft lies in the details. Thoughtful memory, conservative tool exposure, and orchestration that's just enough. What happens when the loop breaks? The system learns. A failed tool call prompts a retry policy and better error parsing. A misrouted case leads to a refined handoff rule. A surprising decision triggers a new validation step. Over time, those small improvements make the agent network feel less like a novelty and more like dependable infrastructure. And to close the loop on expectations, agents aren't magic brains. They're planners and doers stitched together by memory and tools. Their strength is not a mysterious spark. It's the discipline of a loop that can look, act, and learn from the results. If this helped, a like and subscribe helps make more of these.